Okay, so what we're gonna do in this video section or in this video session is to solve some trigonometric equations over given intervals. We're gonna try a lot of different types of examples in this video, and follow along. And if you like this, be sure to share with your friends, subscribe to the channel, and leave us a comment if there's anything that that isn't quite clear. But I'm going to go through several questions, so there should be some clarity once all of these are done. So the first one we have here is secant squared x minus 1 equal to 0. So what I'm going to do, generally, whenever you're solving trigonometric equations, sometimes when you have the trigonometric identities, it can be intimidating. Just set your mind as if you are just trying to solve a regular equation. So first thing we're going to do is we're going to add 1 to both sides. So we have secant squared x equal to 1. And now this is a square. So we're going to find the square root of both sides. And always remember, you have a plus or minus here. So we're going to have secant x equal to plus or minus 1. So what I like to do here, I know most of us learn the unit circle. We focus on sine, cosine, and tangent. So because I know secant is 1 over cosine, this one is pretty easy because it's going to be 1. So this is going to be cosine x equal to 1, and then cosine x equal to negative 1. So we're going to pay attention to the interval. The interval is from 0 to 2 pi. So just remember this about cosine. Cosine is going to be 1 right here and negative 1 right here. So cosine x equal to 1, that's going to be 0 and 2 pi. Cosine x equal to negative 1, that is going to be pi. So the intervals that satisfy, the values that satisfy this equation in the given interval is going to be 0, pi, and 2 pi. So you're going to say x equal to 0, pi, and then 2 pi. Let's try a second example. So we have 4 cosine squared x minus 1 equal to 0. Like I said earlier, just solve like a regular equation. 4 cosine squared x equal to 1. So we divide both sides by 4. Remember, you're always trying to isolate the variable. So we have cosine squared x equal to 1 over 4. And then we find the square root of both sides, making sure we remember plus minus here. So cosine x equal to 1/2. So we're good. Let's get our unit circle together. So the cosine is positive right here and right here. So remember we have a CAST. So cosine is positive in the first quadrant and in the fourth quadrant. And we are always going to remember unit circle is important. So we know that cosine x is equal to 1/2 when x is equal to pi over 3. So we have to remember this is very important. Remember that your pi over 3 is going to be your reference angle. So in the first quadrant, you're going to have it here. And in the fourth quadrant, you're going to have it right here. So we also have cosine is negative in this quadrant here. So cosine is negative here and negative here. So you're also going to have your pi over 3 here. And here you have pi over 3 here also. So now how do we go about this? Pretty simple. This is a plus minus here. So let's go ahead and address each of the cases. So cosine x equal to 1/2. Cosine x equal to negative 1/2. If cosine x equal to 1/2 positive, we're going to have pi over 3. So x equal to pi over 3. And also x is going to be 2 pi minus pi over 3. So 6 pi over 3 minus pi over 3. So this is 2 pi minus pi over 3. So this is going to be 5 pi over 3. And then cosine x equal to negative 1/2. So it's going to be 3 pi over 3, which is in this quadrant here, minus pi over 3. So this is going to be 2 pi over 3. And then here we're going to have pi over 3 plus pi right here. So this is going to be 4 pi over 3. So now for our values in the interval given, we're going to say x is equal to pi over 3, 2 pi over 3, 4 pi over 3, and then 5 pi over 3. So these are the values that satisfy the equation. Now let's go to one more of this type, and this here you can see that we're pretty much trying to we're using the square root method to get the values of x, or the values of the variable that is unknown. Okay, so here we're going to do something similar. So we add 4 to both sides. So we have 3 secant squared x equal to 4. So now we'll go ahead and divide both sides by 3. So secant squared x equal to 4 over 3. So what I'm going to do here, because I know that secant squared is the same as secant squared x is the same as 1 over cosine squared x. So I'm just going to do an inverse here. So we're going to have cosine squared x equal to 3 over 4. So now we're going to find the square root of this right here, square root of this. And the reason why I like to do this is because I know most of us learn the unit circle with sine, cosine, tangent. So there's no point overcomplicating things. So we have here cosine x is equal to the square root of 3 over 2. And remember, it's plus minus here. So we have to remember plus minus here as well. So let's go ahead and find our reference angle here. It's going to be pi over 6. The reference angle for this will be pi over 6. So reference angle is pi over 6. And now we're going to draw our unit circle here. And we're going to, well, let's draw our coordinates here. And we know that this is, cosine is positive here and here. So let's say positive, positive, negative, negative, sine and tangent. So this is pi over 6. So we're going to draw our pi over 6 right here. Then we have it right there. We have it right there. And then we have it right there. So the reason why I do this is because I want you to always remember that the angle is always formed on the x-axis or with the horizontal axis. So you have to identify that. It's very important. So this is 0. This is pi over 2. This is pi. This is 3 pi over 2. And then this is also 2 pi. So now let's go ahead and try to get our values. So we're going to start off with cosine x equal to 3 pi over 2. Cosine x equal to 3 pi over 2. And then we have cosine x equal to negative 3 pi over 2. So let's go ahead and get some values here. So some of our values here would be 3 pi over 2 for cosine x is going to be, we're going to have pi over 6. And then here, which is our next positive one, is going to be 2 pi minus pi over 6. So I like to always write this with the denominator in mind. So this is going to be 12 pi over 6 minus pi over 6. So this is going to be 11 pi over 6. Then when you have negative, this is pi, so this is going to be 6 pi over 6 minus pi over 6. So this is going to be 5 pi over 6. And then we also have plus, because we're going to the third quadrant. Okay, so it's going to be 6 pi over 6 plus pi over 6, so that is 7 pi over 6. So now what are values of x? X is going to be pi over 6, 5 pi over 6, 7 pi over 6, and then we have 11 pi over 6. So these are going to be our values of x. Okay, so now we have this type, we are going to apply our knowledge of factoring. And sometimes, here's what I do sometimes, because I know that the presence of sine can be very confusing. This is usually the first step I take. I'll say something like this: let y equal to sine x. So that way I can get rid of the confusion about sine and all of that stuff, or the trigonometric ratio identity. I get rid of it and it stays out of my mind while I'm trying to just solve a simple quadratic. So this is going to become y squared minus 3y plus 2 equal to 0. So now this is a lot easier to factor. I mean, once you get familiar with the trigonometric ratios, you can factor it regardless. But I know for a lot of students, just from the years I've done this, a lot of students find this confusing. So now we get to our quadratic. So we're going to solve this. This is y minus 2 and then y minus 1 equal to 0. So we have y equal to, I don't like to skip steps. So y minus 2 equal to 0, y minus 1 equal to 0. So we have y equal to 2 and then y equal to 1. So now that we have found the values of y, we can now resubstitute that, and we're going to say, instead of having y here, we're going to say sine x equal to 2, sine x equal to 1. So if we want to, let's go ahead and put together a unit circle. Remember that sine x is 0 here and has, remember with our unit circle, sine and cosine only have the value 0 from negative 1 to 1. So sine can never be less than negative 1. It can never be greater than 1. So when you have here sine x equal to 2, this here is going to be a no solution. And then sine x equal to 1, that's only possible here, and this is pi over 2. So here, x equal to pi over 2. So now we're going to say here that the value of x is pi over 2. That is the only value in this interval that satisfies the equation. Let's go to the next question. So now we have sine squared x cosine x equal to cosine x. This is how I do this. Because you want to make sure you avoid losing values, it's always a good idea to do this. So you have sine squared x cosine x minus cosine x equal to 0. So how do we do that? We just subtract cosine x. This is minus cosine x minus cosine x. Because if you just divide, you're going to lose values. So you want to do it this way. Now that we have this, let's go ahead and factor this equation. So there's a common term, which is cosine x, and then we have sine squared x minus 1 equal to 0. So now we have to say cosine x equal to 0, and then we have sine squared x minus 1 equal to 0. So we're going to get, let's solve for this. We have sine squared x sine squared x equal to 1. So sine x, and we know we did this type of problems earlier, so we're going to do a square root here, plus minus. Sine x is going to be plus or minus 1. So now we're going to find the values of cosine x. So let's do this. Cosine x equal to 0 only here and here. So this is going to be pi over 2 and then 3 pi over 2. And then sine x is plus or minus 1, which is also in the same exact points. So we can say here that x is going to be equal to pi over 2 and 3 pi over 2 within the given intervals. Okay, let's go to the next one. So here we have 2 cosine squared x minus root 3 cosine x equal to 0. So here's what we're going to do. Okay, so here's what we're going to do. We're going to first factor out cosine x because it's a common term. So we're going to have cosine x, and then we have 2 cosine x minus square root of 3 equal to 0. So now we have cosine x equal to 0, 2 cosine x minus square root of 3 equal to 0. So let's add square root of 3 to both sides, square root of 3 to both sides here. So 2 cosine x is square root of 3. We divide both sides by 2. So we have cosine x is the square root of 3 over 2. All right, so again, we'll get our unit circle going, CAST. And we are going to start with cosine x equal to 0 right here. So we're going to have pi over 2, and then we're going to have 3 pi over 2. Now let's go over here. Cosine x equal to square root of 3 over 2. So we know that for this one, the reference angle is going to be pi over 6. So we're going to have pi over 6 here, and then we're going to have pi over 6 right here. These are the only two places where cosine has a positive value. So we have x equal to pi over 6 here, and then we have 2 pi minus pi over 6, which is 11 pi over 6. So therefore, the values of x will be pi over 6, pi over 2, 3 pi over 2, and 11 pi over 6. I just have a general habit of writing them from the least to the greatest. Some teachers care, some don't. It's just a good habit to develop in math. Okay, now we have another instance here. So we're going to first, like we did in the earlier example, we're going to move everything to the same side so we don't lose values. So this is going to be, let's go with minus 2 cosecant x minus 2 cosecant x. So this is going to be secant x cosecant x minus 2 cosecant x equal to 0. So now let's factor out cosecant x rather. So this is going to be cosecant x, and then we have secant x minus 2 equal to 0. So cosecant x equal to 0, secant x minus 2 equal to 0. So let's add 2 to both sides. So we have secant x equal to 2. And here we have cosecant x equal to 0. So what we know here is that for cosecant x equal to 0, remember that cosecant is the same as 1 over sine. So if cosecant equal to 0, that means that sine x is undefined. So this is not going, we're not going to have a value for that one. And then secant x equal to 2. So that, remember, secant is 1 over cosine. So if secant x equal to 2, that means that cosine x is equal to 1/2. So now we are going to go ahead and put together our unit circle. Remember that cosine is positive here and here, first and fourth. So our reference angle here is going to be pi over 3. So this is pi over 3 here, and then we're going to subtract here. So x here is going to be pi over 3, and then we have 2 pi minus pi over 3. So that's going to be 5 pi over 3. So these are your values of x. Okay, finally, we have tan x cosecant x minus 2 tan x equal to 0. All right, so let's go ahead and factor our tan x because it's a common factor here. So we have tan x, and then we have here is going to be cosecant x minus 2 equal to 0. So we have tan x equal to 0, cosecant x minus 2 equal to 0. So we have add 2 on both sides here. Cosecant x equal to 2. And remember that cosecant is 1 over sine. So if cosecant x is 2, sine x is going to be 1/2. So tan x equal to 0. Tan x is going to be 0 here. Let's draw a unit circle here. So here we have, remember that tan is sine over cosine. So you want a position where sine is 0 and cosine is a value. So that's going to happen right on the x-axis. So here we're going to have x equal to 0, pi, and then 2 pi. And then sine x equal to 1/2. So our reference angle there is going to be pi over 6. So we have pi over 6 here, and then we have pi over 6. Remember, sine is only going to be positive right here and right here. So we have our C, A, S, T. So here all ratios are positive in the first quadrant, and only sine and cosecant are positive in the second quadrant. So that's what you're going to have at the back of your mind. So here sine x is 1/2, so we're going to have x equal to pi over 6. And then here we're going to have, this is pi, and we want to account for this angle right here. So it's going to be pi minus pi over 6. So if you want to do that, so remember 6 pi over 6 represents pi minus pi over 6. So this is going to be 5 pi over 6. So now our values of x are going to be 0. Remember I told you I like to write them in increasing order. 0, then we have pi over 6. Then we have 5 pi over 6. Then we have pi, and then we have 2 pi. So this is going to be the answer for the values of x that within this given interval that satisfy this equation. So this is really how simple it can be whenever you're trying to solve this type of equation. So if this video has been helpful to you, please like it, subscribe, and share. Share with as many people taking a free calculus class or college algebra or any of the subjects where this is taught. And I'll see you again. If you have any kind of topics that you'd like us to solve for you, feel free to leave us a message. You can leave it in our community, or you can leave it in a response to this video, and we'll be happy to help you look into it and try to find ways to simplify the approach to solving those types of examples or questions. Thank you, and see you again soon.